Specification of reinforcing bars. Structural requirements. Tensile strength. Bond strength. Ductility. Bendability. Weldability. Fatigue strength. Corrosion resistance. Fire resistance. Tensile strength. Mild steel round bar having grade of steel Fe 250, yield stress 250 Newton per millimeter square, minimum percentage elongation at failure is 23%. HYST bars. Tor 40, bar having grade of steel Fe 415, yield stress 415 Newton per millimeter square, minimum percentage elongation at failure is 14.5%. HYST bars. Tor 50, bar having grade of steel Fe 500, yield stress 500 Newton per millimeter square, minimum percentage elongation at failure is 12%. Tensile strength. This is the most important requirement. Higher strength Tor bars help reduce reinforcement congestion, increasing concrete placement efficiency. Use of different grade of steel in one component should be avoided, to reduce corrosion effect. Bond strength. The bond is due to the surface stresses transmitted between steel and concrete and is measured by the resistance to separate. As we need a composite structure, bond between concrete and steel is of utter importance, as stresses should be able to be transferred easily. Deformed bars develops a bond strength almost 3 times that of a plain rounded steel bar. 2 type of bonds. Adhesion. Mechanical. Type of bond strength. Adhesion bond, adhesion of concrete to the bar. This bond is caused by curing of the concrete surrounding the bar. As concrete gains strength, bondage increases. Mechanical, which is achieved by lugs and helical ribs on the deformed bars or by hooks and kinks in the plain bars. The overlapping oblique lugs and continuous helical ribs provide a perfectly continuous bond. Ductility. It is the elongation at rupture over a standard gauge length is called ductility index. Control on carbon content is important for ductility of steel. It is an important criteria for self-performance of RCC. Bendability. During the process of placing of reinforcement, the reinforcing bar are required to be cranked, kinked or bent. This requires the bar to be made up of bendable material. Bendability is reduces due to the following factors. Increase in yield point of steel. Ribs and lugs tied on the longitudinal bar can reduce the bending ability. As the diameter of bar increases, bending ability decreases. Weldability. Welding generally done using mild steel electrodes. The bar in which carbon content exceeds 0.25% are generally unsuitable for welding. The methods for welding deformed bars are recommended as follows. Electric arc weld. The bar diameter greater than 20 mm. Lap weld with longitudinal beads. For bar diameter 5 to 40 mm. Flash butt weld. For bar diameter 6 to 40 mm. Precaution for reinforcement welding. Avoid overheating of bars. Bar should be properly aligned and kept in correct axis, and it must be supported on either side of the joint. Untwisted ends should be cut off if present at weld joints. Bars should be clean and rust-free. Welding distance should not be less than 50 diameter from curve or bend portion. Fatigue strength. When a structural member is subjected to pulsating force, it may fail at a stress lower than the yield strength of the material. This failure stress is termed as fatigue stress. Fatigue stress needs to be considered only in special cases when a very light structure is subjected to a relatively high repeated live load. Example: bridge. Corrosion resistance. Mild steel or high-yield steel has to be protected against corrosion due to reaction with oxygen, moisture and chlorine in the atmosphere, groundwater or subsoil. The bars are generally protected by providing concrete cover around them or by providing a protective coating. Protection against corrosion depends upon higher grade concrete helps reduces carbonation, greater durability achieved. Quality of concrete around the reinforcement should be good. This can be achieved due to proper compaction and curing. Lower water-cement ratio, higher resistance to the corrosion. Thicker the cover, better the protection to the steel in concrete. Fire resistance. Failure of the RCC structures objected to fire can take place when temperature of embedded reinforcing steel exceeds 500 to 600 degree. See for a stand-up time of 66 to 73 minutes. At about this temperature proof strength of high-yield deformed bars may reduce to 250 to 300 Newton per millimeter square.